Hi everyone. Today also we are going to learn about electrochemistry. This is electrochemistry part 2. Before starting today's lesson, let me remind you what we have learned in part 1 of electrochemistry. Here we learn the galvanic cells or the electrochemical cells and electrolytic cells. How process electrolysis occurs in electrolytic cells. Right, we'll see what we are going to learn today, right? Children, at the end of this lesson today, you will be able to explain the action of the down cell, to define electroplating, to list out the factors to be considered when electroplating, to write properties of electroplated objects, to explain corrosion and rusting of iron, to examine factors affecting rusting, to write chemical reactions of rusting, to find methods to control rusting of iron. Finally, to investigate the effect of other metals on corrosion of iron. Right, children. Now, I am going to explain you how metals, especially highly reactive metals like sodium, magnesium and calcium metals are extracted by the process electrolysis. Can you remember in grade 10 also you had a topic like this. After learning the reactivity series in grade 10, your teachers have told you that highly reactive metals in the reactivity series are extracted by the process electrolysis. Can you remember? Now in grade 11, we are going to learn how this happens actually, right? Just remind electrolysis of fused sodium chloride, right children? Look at here, look at this setup, right? Here there are two types of ions in the solution because this is fused sodium chloride, sodium ions and chloride ions. As we have learned, positive ions are attracted to the negative electrode and negative ions are attracted to the positive electrode or the anode, right? What happens at the cathode when attracting sodium ions towards the cathode? Sodium ions receive electrons from the cathode and turn sodium metal. And this sodium metal get attracted to the cathode. Thereby, we can obtain metal sodium from the cathode. But in this setup, there is no method to extract or separate sodium metal from the cathode. For that, there is a specially designed cell called down cell. Here you can see a picture of a down cell, children. This special cell is constructed in order to separate sodium metal attracted towards the cathode. And also there is a method here in the down cell to separate chlorine gas produced at the anode. Right here you can see anode and cathode are separated in this down cell by a steel mesh. Because of this steel mesh here, chlorine gas produced at the anode does not mix with sodium metal produced at the cathode. Therefore, we can easily separate sodium metal and the chlorine gas, right? Therefore, what is down cell, children? When fused sodium chloride is electrolyzed in the down cell, metal sodium can be extracted by the cathode. Right here you can see another picture of the down cell. See how the chlorine gas is emitted from the anode. It can be separately taken out from this method, right? And there's a steel diaphragm, steel mesh around the anode. This is a cylindrical structure, children. So, at the corner, cathode is placed, and from the cathode, fused or molten sodium metal is extracted out, right? In this manner, sodium metal is extracted. Right, now just look at what happens and what are the chemical reactions take place here in this setup. See the available ions, chloride ions and sodium ions, and what is the anode reaction? Chloride ions are attracted to the positive electrode of the anode and release electrons form in chlorine gas, and the cathode reaction is sodium ions are attracted to the cathode and receive electrons to form sodium metal. Okay, children. Now we are moving to the next application of electrolysis. One application of electrolysis is extraction of metals by the process electrolysis. Second application of electrolysis is electroplating. What is electroplating, children? Coating a thin metallic layer on a given surface used in electrolysis is called electroplating. Here you can see, children, in the solution or electrolyte, the particular metal ion is available. When electric current is passing through the setup, that metallic ion attracts towards the cathode and receive electrons there to form the particular metal atom, right? See, the reactions occur when aqueous copper sulfate solution is electrolyzed, right? You have learned this in the previous part of the lesson too, children. Again, I will explain you here. See, this is a copper sulfate solution, aqueous copper sulfate solution. You know the available ions in the aqueous copper sulfate solution. What are the available ions, children? Copper ions, sulfate ions, hydroxyl ions and hydrogen ions. From those ions, negative ions are attracted towards the anode and positive ions are attracted towards the cathode. Here, negative ions, here the two negative ions available are sulfate ions and hydroxyl ions. Hydroxyl ions at the anode subjected to oxidation by releasing electrons like this, and as a result of this, 2 water molecules and 1 oxygen molecule are produced. As oxygen molecules are produced at the cathode, children, you can observe air bubbles are generating around the cathode. At the anode, children, hydroxyl ions are attracted to the anode and oxidized there. How? When electrons are released by 4 hydroxyl ions, 2 water molecules and 1 oxygen molecule is formed. Because of the formation of oxygen molecules, you can observe generation of gas bubbles at the anode. Then what happens at the cathode? Copper ions available in the solution are attracted towards the cathode and receive electrons from the cathode and become copper metal atoms. As copper atoms are formed at the cathode, they are attracted towards the cathode and cathode is plated by the metallic layer of copper. That's why we observe the cathode, at the cathode we observe cathode turns reddish brown color because of the formation of the copper metal there. Right. Now children, I am going to show you how this happens by doing a real practical. Right. Now look at here. I have two dry cells connected together as the battery and copper sulfate solution. This is blue color copper sulfate solution, right? And the two terminals of the battery are connected to the carbon rods. See, two carbon rods, inert electrodes. Okay. Now I am going to place these two carbon rods in this copper sulfate solution. This is aqueous copper sulfate solution, children. See what happens when I place these two rods in this solution. Right. Okay. Children, look at here, you can observe air bubbles are generated at the anode. Anode is the electrode here that I have connected to the positive terminal of my power source, right? Cathode is the carbon rod that is connected to the negative terminal of my battery. Okay, children, right. Now we'll see what has happened after few minutes. Okay. Here can you see, children, what has happened? This cathode, this particular carbon rod cathode has turned reddish brown copper color. This is due to the formation of copper metal here at the cathode. Okay, right. Let me show you a close-up video of this particular activity. Right. Here these are the two carbon rods. Now you observe the color of the two carbon rods, children. And here you can see how air bubbles are generated, air bubbles are releasing from the anode, right? What is this gas, children? This is oxygen, right? We know that as hydroxyl ions are oxidized, they are at the anode, oxygen gas is released, okay? So, while these reactions are taking place, copper ions in the solution are attracted to the cathode and get plated there at the cathode by turning copper metal. Okay, right. Okay, children. Now finally you can see how copper metal has plated around the carbon rod. This is what we call as electroplating, children. Okay, right. Then we'll see how to plate metal copper on an iron spoon. Please observe this setup, children, right? Now we want to plate copper metal on an iron spoon. So, this iron spoon must be placed as the cathode of our electrolytic cell. See, iron spoon has connected to the negative terminal of the battery. That means iron spoon here is the cathode. And for the positive terminal as the anode, I have placed here a copper plate. Why is that, children? Initially we observed we used only carbon rods and both electrodes are carbon. Now the anode has replaced by a copper plate. The reason is this, children. When we want to plate a certain metal continuously on the anode or on the cathode, children, there should be a continuous ion supply in the solution, right? If we use both carbon rods and only the copper sulfate, dilute copper sulfate solution, there is a limited number of copper ions in the solution. Once copper ions get finished, then the electric flow, current flow stops in the solution, children. Because of that, anode must be replaced by a metal of the same metallic ion in the solution. So, what happens here at the anode? See, children, this is what happens at the cathode, right? Copper ions in the solution receive electrons and turn copper atoms or the copper metals. Then anode dissolves and release copper ions continuously to the solution. When the anode dissolves, you know, anode is copper plate, is a copper plate. When that copper solid atoms dissolves, release electrons and copper 2 plus ions are added to the solution. Thereby, continuously copper ions are given to the solution. When the anode releases copper ions, those copper ions move towards the cathode and receive electrons and turn into the metallic state and get plated. Then this can be done continuously. After plating the iron spoon, you can replace it to another new one and you can plate it also. This can be done continuously by sending electric current. Right, children, now I am going to show you how an iron nail is plated with copper metal. Here, as the two electrodes, I have taken iron nail and a copper plate. Here you can see how the metal copper is plated on the iron nail. I will play this again. See, two electrodes are copper plate and as the cathode, iron nail is placed, right? After few minutes, you can see iron nail has plated with copper. Right, okay. Children, now again come back to the activity we did. Right, here see, I used this copper sulfate solution for plating purpose and now the copper has plated on this carbon rod. While plating, you know, as copper ions in the solution are used and removed from the solution, the blue color of the solution decreases. See, this is the original solution we used, children. Now you can observe the difference of the blue color of the two solutions. This is little dark and this is very light, right? That means this confirms removal of copper ions in the solution during electroplating. Okay, right. Now, we are moving to the factors to be considered when electroplating, children, right? First, the object to be plated should be used as the cathode, right? Here, when the iron nail is plated with copper, iron nail must be placed as the cathode, right? If an iron spoon is plated with copper, iron spoon must be placed as the cathode, right? If we need to plate a bangle with gold, then the bangle must be placed as the cathode. And the anode should be a plate or rod made of the metal that is plated, right? Now, if we are plating copper, anode must be a metal sheet of copper or metal rod of copper. Then, what about electrolyte, children? Electrolyte is the solution we use. Electrolyte should be a salt solution of the metal that is plated. When we plate copper, definitely the electrolyte must be a solution that contains copper ions. Okay, children, if we need to plate silver, definitely the electrolyte must be a salt solution that contains silver ions. Okay. Then, to have a plating of high quality, what steps should be followed, children? The concentration of the electrolyte should be low. Electrolyte must be free from impurities. The object that is plated must be clean, right? By electroplating, it is expected to achieve flowing properties in the surface that is plated. The surface is resistance for corrosion and it has an attractive color. Chemical inertness, that means the surface doesn't react with chemicals, and lustrous nature. Lustrous nature means shiny, of the shiny surface can be achieved. Okay, children, that is about electroplating, and now I am going to ask you some questions. If we want to plate silver on an iron spoon, children, right? What are the changes that should be made in the setup, right? If we need to plate silver on an iron spoon, right? Now, you know, children, iron spoon must be taken as the cathode and the solution must be a solution that contains silver ions. Here, an example for the silver ion containing solution, silver nitrate. And the anode must be a plate or a rod of silver. Okay, right. That's all about electroplating. Okay, children, now we have been discussing applications of electrolysis process. Now, I am moving to a different topic, children, that is corrosion of different metals. Children, what is corrosion? You may have seen some metallic objects like objects that are made with iron or copper or zinc or aluminium. They get tarnished when they are used a certain time, children, get tarnished and their lustrous surface disappears gradually, and some patches are seen on them. Like that, the quality of the surface gets deteriorated with the time, right? Subjecting to these type of changes of metals is called corrosion. But corrosion of iron-made instruments, iron-made objects is different from other metals, children. When iron-made objects or iron-made instruments are corroded, you can observe some brown color powder is formed on the surface of iron, and the surface get deterred and deteriorated, depleted with time. This special process of corrosion of iron is called rusting. Now we are going to inquire about rusting process. Okay? Here you can see the pictures of corroded metallic items. Rusting is a process in which iron metal reacts with moist air present in the atmosphere to form iron oxide. Iron oxide is here, children, Fe2O3. This is also called ferric oxide. When metal iron reacts with atmospheric oxygen gas and water vapor moisture, iron reacts and iron is subjected to chemical changes. Finally, a compound called ferric oxide is formed. This special process is called rusting of iron. Finally, the rusting is a rust. Iron rust is a reddish brown color substance. This rusting leads to heavy damages to the iron-made substances. That's why we are learning about rusting, children, because we must find some steps to prevent iron from rusting, as it gives us some economic loss. Okay, right. Here you can see further, you can see some rusted objects. See, when they are rusted, they cannot be used again and again. So, durability of these instruments, these objects decreases. Then time to time we have to replace these things with new ones. This is an economic loss for us. That's why we are learning how to control rusting of iron. Okay, before learning steps to control rusting of iron, let me tell you what are the essential factors for rusting, children. Here you can see air and moisture are essential factors. There are some simple activities that can be done in our lab to find out whether air is needed for rusting and whether moisture is needed for rusting. Okay, now we are going to do this activity really and see the relevant observations. Okay, right. See, this is the activity that we can implement in our school lab to find out whether air is essential for rusting. Okay, children, here in this diagram, please observe this diagram properly. You can see there are two test tubes with clean iron nails, right? And for B test tube, we have put boiled water, and for the test tube A, normal water, right? And on the boiled water layer of B, coconut oil, a layer of coconut oil is placed, right? After arranging this setup, you have to keep this setup 2 days, right? When you observe after 2 days, children, you will observe the nail in tube A has rusted, but the nail in tube B has not. Why? Let me explain the reason, children. Right? The nail in tube B has enough water in it, but there's no air. Why? When water is boiled, air dissolved in water removes. As there's no air for this iron nail hasn't rusted. And air from outside also cannot enter the tube because of the coconut oil layer. But for the nail in A, there's water and air too dissolved in that water. So, as both factors, air and water available for nail A has rusted. Right, I will show you, children, the real setup that we can arrange to do this activity. Okay, right. Here I have 2 nails with, here one nail has only water and the other one boiled water and a layer of coconut oil. See, so I made this, I arranged this 2 days before. So now you can observe the difference of the 2 nails, children. Here the nail only in normal water has rusted and the nail in boiled water test tube has not. Okay, right. Then we'll see whether water is needed for rusting. Before that, children, I must tell you one more thing. Right now in this activity we said that air is essential for rusting. Air means a mixture of number of gases, right? So, which component in air is essential for rusting, children? Actually, which component? Now, there is another activity to see that which component in air is needed for rusting. Okay, right. Let me show that. This is the activity we do to find out which component in air is needed for rusting. Right, children, now you can see 2 test tubes. 2 test tubes are inverted in a trough of water. Here in this test tube also water in this much of level. I will explain this, children. Before arranging this setup, right, this is what we do. We have to take a trough of water like this, and again we have to take 2 test tubes. For one test tube only, some iron wool are inserted, and then both test tubes must be upside down and inverted and inserted into this trough of water. Right, now this is iron wool. Okay, right. After arranging this setup, you have to keep this few days, 2 days, right, 2 or 3 days. Then what can you observe? You can observe only in this particular test tube with iron wool, water has gone up. Iron wool also has rusted, right. That means for rusting purpose, one component of air, a certain air gas component in this tube has used. Normally, only 1/5 of total volume of air in this test tube has gone up, children. Then we can have an idea on which the gas used for rusting of iron wool is the component of the gas having 1/5 of the volume of total air. Which gas has the 1/5 of the total volume from the normal air? That is oxygen. Because of that, we can decide this particular gas used up for rusting is oxygen. Understood, children? Right. Okay. Say, these are the observations that I explained to you, and this is how we decide which gas is really used for rusting. Right. Now we are moving to another activity. This activity is done to test whether moisture or water is essential for rusting, right. For this, here we have to take 2 boiling tubes, children, and for one tube, anhydrous calcium chloride is inserted. The purpose of inserting anhydrous calcium chloride is to absorb water vapor inside the tube, children. This anhydrous calcium chloride absorb water vapor. So, there is no water vapor inside this particular B boiling tube, right. And here in this A boiling tube, there is a little amount of air and water vapor too. But in B, there can be air but no water vapor, right. Then when you observe after few days, you will observe in the tunnels in the tube A, the parts inside and outside both have been rusted. But in the case of B, only the parts of the nails which are outside the tube have been rusted. By this, what we can confirm, children? Here, the parts are inside the iron nails have not rusted because there is no moisture in this tube. This confirms moisture is essential, water is essential for rusting. Okay, I will show you the real arrangement here. These are the setups, 2 setups used, children. Here these are calcium chloride, anhydrous calcium chloride, right. This is the real setting. Then you can get an idea on how the setup is constructed, right. As I made this, prepared this in the morning today, now the iron nails are not properly rusted. It takes a time for rusting purpose. Okay. Right, children. Now we have understood what are the essential factors for rusting. There are some more factors affected rusting, children. There are factors which accelerate rusting. These factors are acids and salts. Acids and salts accelerate rusting, but bases slow down rusting. Okay, children. Now, these simple activities show you acids speed up rusting. Children, when 3 test tubes have to take like this, and 3 clean iron nails must be placed on inside them, and then here normal water mixed with lime juice, water mixed with dilute hydrochloric acid. When you arrange these setups and kept few hours and observed, you will observe that iron nail in C has rusted more and B little, and iron nail in A very less. That means acids, these are acids. Acids speed up rusting, right? And salts too speed up rusting, children. See, here 2 iron nails, clean iron nails. One is placed in normal water and the other one is placed in dilute sodium chloride. It's a normal common salt solution. When you place these iron nails and observe after few hours, you will observe iron nail in B with sodium chloride has rusted more than that. That means salts speed up rusting. And as I told you earlier, bases slow down rusting, children, right? Here as the base, sodium dilute sodium hydroxide solution is taken and 2 clean iron nails are placed in them. When you observe after 1-2 days, then you will see the nail in normal water has rusted, but the nail in sodium hydroxide solution has not. That means bases slow down rusting. Okay, right. Right. Now, we know how rusting occurs and what are the factors essential and what are the other factors affecting rusting. And also we know rusting is a problem. It's a problematic process. Therefore, we must find steps to control rusting. What are the steps that can be followed to control rusting? Anyway, children, to control rusting, what we have to do? We must protect the iron and we must prevent the iron by getting contact with the essential factors like air and moisture. If we can prevent iron getting contact with air and moisture, we can prevent iron from rusting. For that, we can apply paints, grease or oil on iron. Iron can be coated with other metals like tin or copper. Galvanizing is also done to protect iron from rusting, to control iron from rusting. Okay, here you can see the methods, right? This is painting to control rusting. This is galvanizing, right? Galvanizing is, children, dipping iron-made instruments in a molten zinc solution, zinc liquid, melted zinc, right? This is called galvanizing, right? Then, let me explain what really happens during rusting, right? Children, remember, rusting is a chemical process. There is a series of chemical reactions in rusting, okay? Right, these are the reactions occur on iron surface when rusting. See, suppose this is an iron material, iron made thing, and this is a water drop, right? It's an enlarged water drop. So, what happens when iron is in contact with water and oxygen too? Iron starts oxidizing, children. When iron oxidizes, you know, electrons release and Fe2 plus ferrous ions are formed. When the ferrous ions are formed, iron starts to dissolve. Thereby, the surface starts getting corroded or rusted. Right, children, let me show you the chemical reactions occur on iron one by one. Right. First, when the iron is exposed with water and oxygen, iron oxidizes by releasing electrons and ferrous ions are formed. After few hours or few days, this is a long-term process. Okay. After few days, water and oxygen near iron receive electrons emitted by iron like this and turn into hydroxyl ion. As iron releases electron, children, it is oxidation. It's an oxidation reaction. As water molecules and oxygen gain electrons, receive electrons, it is a reduction process. Then there are two reactions, oxidation and reduction takes place here. Then what happens? Ferrous ions react with hydroxyl ions in the medium like this and form ferrous hydroxide. Ferrous hydroxide. Finally, this ferrous hydroxide further reacts with oxygen gas available in the medium and turn ferric oxide. This is Fe2O3 is ferric oxide, children. Why there's one H2O, dot H2O? That means this ferric oxide formed here has some water molecules binded to it. When some water molecules are binded to any chemical compound, children, it is called hydrated chemical compound. Therefore, this is called hydrated ferric oxide. This is what we call iron rust. This is reddish brown color, children. This is specially called hydrated ferric oxide or iron rust. This is what happens during rusting, children. Okay. Then let me explain effect of other metals on rusting of iron. Now we are going to learn effect of other metals on rusting of iron. Right. Look at this picture, children. What you can observe here, what you can see here, when the iron nail is in contact with a highly reactive metal than iron in the activity series, that highly reactive metal starts oxidizing first and it prevents oxidizing of iron. Right, children? When the iron nail is in contact with a less reactive metal in the activity series than iron, like copper or lead, then iron nail starts to oxidize first and other metals do not oxidize. This can be proved by an experiment, children. Look at here, right? When only the iron nail is in water, it rusts so slowly. When the iron nail is in contact with metal tin, it rusts faster. When the iron nail is in contact with metal magnesium, it doesn't rust. Okay. What happens here? To inquire this, we have to use a particular experiment called agar jelly experiment. In this agar jelly experiment, this is a kind of jelly. It's a white powder. When it is dissolved in hot water, a jelly can be prepared, and when the jelly is prepared, we add two indicators to that. The two indicators are phenolphthalein and potassium ferricyanide. Phenolphthalein, normally you know that, turns pink in the presence of hydroxyl ions. Potassium ferricyanide turns dark blue color in the presence of ferrous ions. Right, now we are going to recognize whether hydroxyl ions are formed in the medium or whether ferrous ions are formed in the medium. If the iron is corroded, if the iron is rusted, first iron oxidized and ferrous ions are formed. If ferrous ions are available in the jelly medium, potassium ferricyanide turns dark blue color. By observing that, we can come to the conclusion that iron has started rusting. Okay, right. Look at here. This is what the agar jelly practical. See, here when only the iron nail is placed in this agar jelly, part of the iron nail, around one part of the iron nail here, pink color is appeared. The bottom part, dark blue color is appeared. That means in the dark blue color area, ferrous ions must be available. That means iron has oxidized. In the pink color area, hydroxyl ions must be available. That means reduction reaction has taken place in that particular area. Here when the iron is in contact with zinc, here you can see this is also pink color. When the iron is in contact with copper, here what has happened? Dark blue area is higher and only the pink area is seen at the middle where the copper metal is in contact. Let me explain the reason for this, children. Before that, just go to the real experimental setups that I have arranged for you. Here only iron nail is placed in the agar medium, and you can see the head of the iron nail has dark blue area, it has turned dark blue, and the down area pink. Here iron is in contact with, this is magnesium metal, children. This iron is in contact with magnesium, only complete area is pink, and here iron is in contact with zinc, only the pink color is seen, right? When iron is in contact with copper, this is a copper strip, you can see around near copper strip pink color is seen, and near iron blue color. Here this is iron is in contact with lead, metal lead. Here around metal lead pink color, and near the iron nail blue color. Right, okay, we'll see the reactions relevant to this. See, when the iron nail is in agar medium, pink color, appear in pink color, indicates that reduction reaction has taken place near that. As hydroxyl ions are formed, phenolphthalein in the medium turns pink color. Right? Appear in dark blue color shows and indicates that oxidation reaction has taken place and ferrous ions are oxidized to form ferrous atoms are oxidized to form ferrous ions. Right. Okay. Here you can see when the iron nail is in contact with copper, see, reduction reaction takes place near copper and oxidation takes place near iron. Right. That means iron corrodes fast when copper is in contact with iron. Right. When iron is in contact with the metal zinc, see, reduction reaction takes place near iron and oxidation takes place near zinc. That means instead of oxidizing iron, zinc metal is oxidized and zinc sacrifices itself to protect iron from rusting. When zinc is oxidized, iron doesn't oxidize and iron become the cathode here and get protected from rusting. This is called cathode protection. Children, to protect iron from corrosion, a metal above in the activity series can be kept in contact with iron like zinc or aluminium, right? Then what will happen? Iron acts as the cathode and gets protected from corrosion. This is called cathodic protection. Protecting iron by making it the cathode of an electrochemical cell is known as the cathodic protection or sacrificial protection. Here these are the instances where cathodic protection is used. What are the instances? Galvanizing, coating iron-made objects such as buckets, barbed wires, roofing sheets, GI pipes with zinc. This is called galvanizing. Okay, with that we have come to the end of the lesson today, children. Right? I hope that you all got a very good understanding of the lesson electrochemistry. Right. Okay, thank you very much for being with me, being with us. Goodbye, children.